Hi, we're Intelligent Irukandji, and our final project is called Irukandji Disease Diagnosis. What our website does is figure out your disease based on the symptoms you have, and our website uses artificial intelligence-driven machine learning to provide you with valuable health insights that have up to 99.7% accurate disease diagnosis, and now there's no need to see a doctor. But before that, we should answer the big question. What is an Irukandji? It's an overcomplicated jellyfish. This is our team. I'm Manci, and I did the machine learning for logistic regression, the front end of the website, and I worked on the video.
I'm Benjamin. I mainly worked on the Canon model and like the visual sections of like the website we made.
Hi, I'm Sebastian, and I mostly worked on the random forest classifier and the sidebar of the website.
Hi, I'm Michael. I worked on data pre-processing, the website, and the diagnosis tool.
And then hi, I'm Kaylee. I worked on the website, diagnosis tool, data pre-processing, and the decision tree classifier. So the problem that we were trying to solve is that in some cases, some people cannot afford to take days off of work when they are feeling unwell to seek advice from a medical professional, while in other cases, some people just may not have the time to spare to go visit the doctor's office to get a diagnosis and correct medication prescribed to them to help with the symptoms they are experiencing. So oftentimes people may feel like they took time off of work or out of their daily schedules for a small issue when they find out that they only have like a cold or other minor illnesses that can be cured by over-the-counter medication that can be purchased from their local drugstore or pharmacy. And then so our solution to this problem is that as a result of these issues, we have designed a website that will allow people to see the probability of them having a particular illness or disease and allow them to be aware of the severity of it. On this website, they will be able to check off the symptoms that they are currently experiencing, and based off of the ones that were checked, the website will work to generate the probability of them having a certain disease or illness. And then based off of the severity of the disease or illness with the highest probability, they will be able to make the decision of whether or not they should seek advice from a medical professional to get a more accurate diagnosis of their illness or disease, as well as a prescription for the correct medication that they should take to quickly improve their health conditions.
So for our project, we used Python for the EDA, HTML and CSS for the website, and then frameworks we used include sklearn and pandas for our visualizations, and then on the website, we used Bootstrap and Replit. So when it came to the EDA and pre-processing our data, the first thing we did was we organized non-numerical data, so the disease names, into numbers using a dictionary. So AIDS would be 1 and so on, so that everything in our data set could be numbers, and then we mapped it into our data set. And then we split, trained, and tested all our data for our initial design. Then using multiple different models, we looked at mean error and accuracy scores to see which models would be best. And based on these, we selected and evaluated the models that worked best for us.
Then we use K-nearest neighbors, or KNN, which is a machine learning algorithm that uses distance measuring to find K-nearest neighbors or data values to like find a new unlabeled data point. We utilized it in solving our main problem by classifying sets of symptoms from like this one big data set we had. We then used the value of 5 nearest neighbors, and then classified them into a closest designated disease, and like then fit all the results onto various visualization models such as like heat maps or confusion matrices. With the KNN heat map, our total error score was 0.05, which is like, that was probably one of our most accurate model. It also had an accuracy score of 0.82.
Logistic regression. So we use logistic regressions, and what that is, it takes information and tells you the chances of one of two choices being true, and it's a classification model, and it is used in various machine learning such as statistics, medical research, social sciences, and more. Some pros and cons to logistic regressions are our accuracy and error results. So our model that we use, it had an excellent accuracy, but when we utilized logistic regressions for our website diagnosis, we saw that it was always defaulting to AIDS. So we switched it over to random forest. And now for some pros and cons to logistic regressions. It's simple and easy to implement, efficient for small and medium data sets, and efficient for probabilistic predictions. Some cons is that it's biased to the majority class, limited to only 2 classifications, and it's sensitive to outliers.
A random forest classifier is a form of machine learning that utilizes multiple decision tree classifiers to give an output. To give an output, the decision tree classifiers first give their outputs for the data they were given, and the random forest classifier outputs whichever output was most common among the decision tree classifiers. This method is much more accurate than an individual decision tree classifier, having a near perfect average accuracy across 20 tests.
And now for a demo to the official website of Irukandji Disease Diagnosis. So we have our front page, and it shows our purpose and mission, and a disclaimer, and our video. On the left side, we have our sidebar, and we have our self-diagnosis. So you can check off the symptoms that you have. We have lots of symptoms. And then you can submit it. And once you submit it, you get your diagnosis, and it's in alphabetical order, and it gives you the percentage of how high your chances are that you have the disease. And then we also have our AI dataset backgrounds, which shows a pie chart of the frequency of diseases we have. We have a pie chart and a bar graph that shows the frequency of diseases and symptoms. It's very colorful. And then we have our machine learning models. So each of them have a confusion matrix heat map. We have logistic regression, k-nearest neighbors, and random forest. Yeah, and then we have our team page as well. Our team page, and it gives us a bio of all of us. And then we have other information that links to a website, to an actual health website. Yeah. Thank you.